I believe you can hear me. So we need to start this live, whereby we shall discuss shall have a final discussion on this Unit 3 Practical Skills paper. And if you are joining and you are new to Proflan YouTube channel in this particular time, I'm requesting you subscribe. Also, you can be able to share this live to your friends, encourage them to join. If you are new to Proflan and you don't know about our Patreon page is where we usually add this particular PDF so that you can be able to access the PDF on this. So anytime you like to have to download the PDF, you will be able to do it. Now, welcome to this final discussion of Unit 3 IAL Physics. We shall go through this paper. This is one of the paper that was done in one of the year, so that we can be able to have a chance to look at how the questions are asked and what's the best practice you can be able to use in order to maximize the marks. So one of the question that was asked here, and you'll be seeing such kind of questions in your paper, in your coming paper, is whereby you are supposed to draw a label diagram showing how you can be able to carry out an investigation. But what was the investigation about? The student was asked to investigate the changing temperature of a diode, how changing temperature of a diode will change the potential difference which the diode must start conducting. So in that, we must have a diode well labeled here. We have a diode. I included a water bath which is heated by the electrical heater so that the temperature can be varied. Then we'll be able to check how are we going to measure this particular temperature. We are going to measure that. We are going to check the temperature of the water by using the thermometer. So once we have looked at that, ensure that you have a source of power supply, and then we have a variable resistor which could be able to vary the current in that case. Also, don't forget that we were looking at the idea of the conductivity, right? So we are going to include the ammeter, which is always connected in series with the other component, and we have a voltmeter which is connected always parallel to the component where you have to measure the voltage. So this is the circuit you could come up, and this kind of circuit is going to vary depending on what you are asked in a question. But you have to have an idea because you did electricity and circuits, you did how to connect different components in Unit 2, that is electricity and waves. Right. So moving down, we get to say you may be asked identify the safety features. You are going to be asked question to do with safety and precaution that you are going to take. For instance, if you are having a scenario whereby you have to do some connection of electricity and the electrical component, the safety feature there, the hazard there is getting having a risk of getting electric shock, right? And also something that you need to remember is that for you to prevent for you to protect yourself against that, you put on gloves so that you don't come into contact with the electrical live wires. Also, you can be able to reduce the amount of voltage in the power supply. Right? So if you are given a practical whereby it's involved for mechanical apparatus, you have heavy masses, that means that you have to protect yourself against those materials hitting your feet. So maybe you can be able to wear protective boots, isn't it? Yeah, so if there is a scenario whereby you are dealing with lasers, laser lights, you wear protective goggles. So you ensure you have an idea how you are going to answer such kind of question, because in this practical skill paper, they have to test you on those practical skills and how you are able to protect yourself when you are carrying out practicals. Right, so scenarios where you are cutting or you are using knives, you have to protect yourself by you putting on gloves, right? Risk of electric shock, we have said, is reducing the power supply. And also, if we are talking of water, hot water, you have to protect yourself by putting on aprons, you putting on gloves, so that you can risk burning your skin and so forth. In question 2, we are told a student investigated the relationship between mass M a boat can carry and the depth D below the water the boat will go. So meaning that when you add the mass, the boat will keep on sinking, and in that case you can see the beaker is just modeling a boat, because if you add some masses, the beaker will keep on sinking. That is exactly what happens to the ships in the ocean and also the boats. Show that upthrust could be calculated using this particular equation. So in this case, the examiner is trying to check whether that this student understand how to derive equations, and we are told that D is in centimeters. So if D is in centimeters, then it means it has to be converted to the right units, and in this case, if we are told that the density is in 1 gram per centimeter cubic, so we can be able to proceed from there. So the first thing that we need to remember here is that the volume of water displaced is equal to the volume of this cylinder that is inside the water. So if we know the cylinder, the volume of the cylinder within this region, will be able to know the amount of water displaced. And we understand that the volume of a cylinder is pi r squared, and we can also use the concept that pi r squared h, that is the volume, but our h is d, so that's why you can see I said volume is equal to pi r squared d, because the height of that cylinder was d. The density of water is given by the formula density is equals to mass over volume, but we want to know the mass of water displaced. In that case, we are going to say mass is equals to density times volume. Already we have gotten the volume here, and we have the density as 1 gram per centimeter cubic, and then we can be able now to say I can convert my values to meter cubic. So the density now, it was in gram per centimeter cubic, I converted to meter cubic, and the radius was given in centimeters, I had to convert it to meter cubic. So the volume should be in meter cubic, density should be in a kilogram per meter cubic. So you can see this million here is going to cancel with 1,000, then we're going to remain with our mass being equivalent to pi r squared d over 1,000. That's mass. But we know that upthrust is equal to the weight of the liquid displaced. So if the mass of the liquid displaces this, then it means we can comfortably say that weight is mass times gravity, and if we multiply here, we shall get our final answer being equivalent to upthrust is equals to pi r squared d g over 1,000. So which means that sometimes examiners can be a bit tricky, and they can try to misbehave around by giving you questions whereby you're supposed to derive. I've not seen much of these questions being asked, but sometimes the examiner can decide to mess around with you by giving such questions. So that's why I decided, because I've been doing series of different papers, and then we have not encountered a question like this, yeah, for quite some years. This was 2020 January. So 2021, 2022, 2023, and 2024 up to 2025, much of the question to derive have not really been so much prominent. But what I mean is, if the examiner try to misbehave and bring a question like this, be ready to tackle it and be ready to do well. And before we proceed, I need to bring to your attention that Proflan YouTube channel has a Patreon page where we can be able to access the PDFs of these papers that we are doing here, so that you can be able to go there and download. Just make sure you run in Proflan Patreon page so that you can be able to access. All right, so moving down to the next part, let's see what was in store for us in that case. The student marked the position of water surface on the beaker for different values of m. Yeah, so you can see different masses were added, and then the depth was recorded. So then from there, the experiment was used to draw a graph of depth against mass in grams. When the beaker is in equilibrium, upthrust is equals to the weight. Yeah, so that is exactly what we have already mentioned. And in that case, we are told that, and density is given by 1 gram per centimeter cubic. Determine the diameter of the beaker using the information. So the first thing that I did is because you can see the graph that we are drawing is a graph of D against M. So which means that I needed to have D as the Y value, because we have Y is equals to MX plus C. Yeah, so D is the Y part. So I decided to rewrite this equation so that I have D as the Y part, and that is exactly what I did here. By rewriting, I had D is equals to 1 over pi rho pi r squared m. And then we can see now, if you relate this equation that we have here, Y is equals to mx, you can see our x is m and our Y is D. Then this part that we have here is going to be our gradient. So if we work out the gradient of the graph, we're gonna have that gradient is equals to 1 over rho pi r squared. Then I decided to use this particular point here, and I also used this point here, and I worked out the gradient. So using those points, I got my gradient to be 0.26, and that will mean that we can now be able to make it such a way that we equate the gradient to 1 over rho pi r squared. So which means if you make r squared the subject of the formula, we are going to get our value as what? As 1 over rho pi times the gradient, and then we need to find the square root in order to work out the radius. But the question was asking us to work out the diameter. Once you have the radius, you can go ahead and then work out the value of the diameter, whereby you have to remember that diameter is equivalent to twice the radius, and that's exactly what I did to get my answer as 7. It was observed that the graph shows the beaker will have a depth under the water with no mass. So you can see from the graph that we are having here, when there is no mass, the depth of the glass will be somehow, it will be around 1.6. Yeah, so why is that? Why is that? It's because the mass of the glass was not considered when this experiment was done. So what could have been done is that in order to correct this systematic error, the depth when the glass has no mass should be subtracted from each of the values of D, so that the graph can start from the origin, right? Or whenever the mass was being considered, they could have included or put into consideration of the mass of the beaker also before starting to plot a graph. So identify the sources of the systematic error in that case. This is because the mass of the beaker was not included in the investigation. So in order to correct it, the beaker should be added. The mass of the beaker should be added to the mass of the load, and then plot the graph. Another way we have said, or it could have been done by subtracting the depth when there was no mass, and then when during the zero mass. So they could have considered that as well in order to ensure that they get the right results. Another concept that can be asked in this paper is the concept of refraction, but the most important thing is how do you answer questions, practical skills questions whenever they are given. You need those skills. You need to know how to answer or carry out different experiments because all these experiments were done in Unit 1 mechanics and materials, and also they were done in waves and electricity. So the student investigated the refraction of light as it travels into salt solution in different densities. For salt solution, as the density increases, the speed of light in the salt solution decreases. So which means if the speed decreases, it means the refractive index increases in that case. And describe the method the student could use to determine the density of the salt solution. That's actually the experiment to determine the density of a liquid. So the student should measure the mass of the salt solution using an electronic balance. So maybe the student could have an electronic balance there, which is having, and then place some solution, maybe place some liquid in that. Okay, this will be the measuring cylinder. So the student could measure the mass of the measuring cylinder empty and then record the reading. Maybe that is M naught, and then put some liquid salt solution in the measuring cylinder, and that will be M2. So which means that for you to get the mass of the liquid, you need to subtract the 2. So that's how the experiment can be carried out. Then also using a measuring cylinder, you should measure the volume inside the measuring cylinder and ensure you look at eye level, at this particular level, such that you avoid the error of parallax. Yeah, whenever you are taking the measurement, measure the volume of the liquid and then calculate the density using the formula density is equal to mass over volume. So in that case, this is the formula could have used in order to work out the question. Proceeding to the next question, the student increased the density of salt solution by adding different masses of the salt, and then you are supposed to sketch the graph to show how the refractive index. So the graph will start from at some given point and then work out, draw the graph in such a way that the graph is the density, the refractive index increases as the mass increases. Yeah, so the graph was supposed to look like that. The relationship between the refractive index and the angle of incident theta 1 and theta 2, the angles that we are talking about. Theta 1 is the angle of incidence and theta 2 is the angle of refraction. The relationship between those two angles and the refractive index in this case is given by the formula sin theta 1 equals to n sin theta 2. So describe a graphical method you could use to determine the refractive index. So you can see this graph is y is equals to mx, and in that case it's a graph that passes through the origin. So which means we are going to draw a graph of sine 1 over sine 2, then we are going to get a straight line. And to get the refractive index, it will be the gradient of this line that we have obtained, and that is exactly what I've described in these instructions. I've said using a protractor measure different angles, at least 5 pairs of theta 1 and theta 2. So we are going to have at least 5 pairs of angles in that case, so that we can be able to plot a graph of sine I against sine theta 2, sine theta 1 against sine theta 2. And I've said that from here we are going to get, or we are going to obtain, a straight line graph, and from this straight line graph, of course, we can be able to work out the gradient. So which means that if you have sine 1, theta 1 and we have sine theta 2, we shall have a straight line graph that is like that. So which means in order for you to work out the refractive index that we are told here, we are going to work out the gradient of this line, and that is going to be our refractive index in that case. If you are new to Proflan YouTube channel, consider subscribing so that anytime we are going to do more tutorials, you'll be notified. And also you can join our Patreon page so that you can be able to access the PDF I'm currently working on, so that you can be able to download and continue with your revision. All right, so moving further to the next question, we are told the student measured only one pair of angles for each solved solution. The measurement of student recorded for one solved solution is angle of incidence theta 1 is 33 degrees. Angle of refraction theta 2 is 24 degrees. Refractive index is 1.34. The uncertainty of the measurement of the angle is positive or minus, plus or minus 0.5. Calculate the maximum and minimum value of refractive index. So at this given point, something that you really ought to have remembered is that you can be able to find the maximum angle, also you can be able to find the minimum angle. So for you to find refractive index, we know refractive index is sine of theta 1 over sine of theta 2, but for us to have maximum refractive index, we have to ensure that theta 1 is maximum. So that is going to be 33.0 plus 0.5, and that's going to be 33.5, and sine theta 2 should be minimum, so we have to subtract 24 minus 0.5. So if you work it out, you are going to get your answer as 1.384 as the maximum refractive index. And for minimum refractive index, we have to ensure theta 1 is minimum, theta 2 is maximum, and that is going to give us 1.296 as the minimum and the maximum value of the refractive index, as we have gotten them here. To calculate the percentage uncertainty, we are very sure that there will be a question on calculating percentage uncertainty. Now, if you are given more than two values, for you to work out the percentage uncertainty, you need to work out the range, then the uncertainty will be the range divided by 2. So if you have more than two values, you need to work out the range of the values, and that's going to be the uncertainty calculated from the range. And to get the uncertainty from the range is range divided by 2. And then we are going to, that is exactly what I did here. The range will be sorry guys, I'm having some cold, but now that we are going to do this exam, I decided that I have to ensure that I take you through this, even if I'm not okay, to ensure that you are ready for the exam. Yeah, so sorry for that. So we have the range, and then we subtract the range. The range is the highest value minus the lowest value. Maximum minus minimum divided by 2 gives us the uncertainty to be 0.44. And then percentage uncertainty is uncertainty divided by the mean. The mean of the two values is this value plus this divided by 2. But already we were given what the value was, which is 1.34. So we are going to say the uncertainty divided by 1.34 times 100, and that gives us the value of 3.3%. In question number 4 is a question that is going to enable us get to know what do you do, how do you criticize the the data that has been collected. So in order to criticize the data on the table, you are going to look at the consistency of the number of decimal places recorded and number of significant figures. And we are also going to check, is the interval between one measurement to the other uniform, so that you can be able to observe the trend, what's happening. Criticize the results. If you look at this table that we have here, especially for the GPE here, we have 3 significant figures, we have 2 significant figures, 3 significant, 2 figures. So this guy is not consistent. Yeah, so the inconsistency of number of significant figures in the GPE is one idea that we have really to look at. So there must be consistency in the number of significant figures in the calculated data. And also we can see the mean value should be calculated in 3 significant figures. So you can see here we have 3 significant, 2 significant figures. So we have to ensure the mean should be in 3 significant figures. So the range, the interval of the masses added is correct. See, they're adding 0.2, 0.2 all the way, 0.02 all the way, which is quite okay. So check the number of significant figures recorded, and also some other tables you may find. The data corrected to be used to draw a graph is very, very little. So if you find the data correct is around 4 figures, that cannot be able to give us a line of best curve or line of best fit. So also the number of data collected is also important. So always check on that. Another aspect that you need to check also whenever you are criticizing this data is trying to look at the value of on the each column is the units indicated. Yeah, if the unit is not indicated, you have also to identify and criticize the data collection at that point. Now complete the row. You may be given a question to complete the row or the information missing. Basically, like for instance here, they are trying to check, do you know how to calculate gravitational potential energy? That's the concept they were trying to check. So gravitational potential energy is equals to mgh, and you have to ensure that the dimensions are, or the measurement taken are in the correct units. So because here like 75 centimeters, it has to be in meters. And then we have the mass, then we can be able to say gravitational potential energy is equals to mgh, which is 0.12 times 9.81 times 0.75 in meters, and that becomes our answer in that case. The second part of the table, we were being tested whether we know how to work out mean. We are going to add this plus this, divide by 3, so that you are going to get your answer as 3.34 at that point. Another practical skills that will be tested in this paper is to draw graphs. So they may plot points and then they tell you to draw line of best fit or curve of best fit, or they may give you a blank and complete empty graph. Then you are supposed to plot that graph. Something that you need to understand, you have to put the quantities where they are supposed to be. So like for instance, we shall have potential energy in the y-axis and energy supplied on the x-axis. You have to label that, and also you have to ensure you are including the units on the labeled axis. You have to ensure the units are well indicated there. Another thing you have to ensure when you are plotting this graph, you have to choose a scale that will enable you to use almost 3/4 of the graph. Your graph should cover almost 3/4 of the graph. For you to earn those points, ensure you plot all the points properly for you to earn the marks. Determine the efficiency. In this case, the question the student was asked to determine the efficiency. Remember, we have just worked out gravitational potential energy. That is the useful form of energy, and the energy supplied is the mean energy. So the input energy, we know efficiency is useful energy, yes, over total input total input energy times 100. So that's why you can see if we have gotten a straight line graph, it will mean for us to get the efficiency, we just work out the gradient of that graph, and if I times it by 100, I'm well and good to express my gradient, my efficiency as 27. Sorry, this is going to be 25%. Yeah, so this actually, let me check it. That could be an international crisis there. This 0.995 divided by 3.5, which translate to, no, this is going to be, I think the error was here. The error was here, so it should be 0.27, so it should be 0.27, so that we shall say it's 27%. So things can happen, anything can happen in an exam, so you have to be very careful you don't cause this kind of random errors. This is what we call random errors when you are working out questions. Yeah, so you need to describe how you should collect and use the data to determine the mass at which the efficiency starts to decrease. So you see in this region here, efficiency is directly proportional. The efficiency is constant. So if it starts to decrease, the graph will start behaving like that. That's what it means. It's the efficiency decreasing. Efficiency is the gradient, isn't it? So meaning if the gradient of the curve decreases, if the gradient of this curve decreases, it means the efficiency has decreased. But how do you get this particular point where the efficiency of this start decreasing? This is exactly what we are going to do. This is what I said we are going to do here. Continue increasing the mass and extend the graph. Yeah, identify the point where the graph starts to curve. Take small, at that point where the graph starts to curve, take small increment around that point, and then we can be able to get a curve or best fit. Yeah, so that we can be able to get a curve or best fit, and then we can be able to identify at which mass does it, yeah, and at which energy does it start to curve, so that we can be able to do that. So basically that's what we are going to do, and we have question number 5, which is the last question in this discussion. We are going to look at the photograph shows the bungee chamber. The bungee chamber falls through the large distance and then decelerates the bungee rope. Yes, so which means that I don't know whether you have ever had this experience. I had it once, I'll never try it again. Yeah, so the safety bungee rope need to be tested to ensure that it withstands the stress applied to it as it accelerates the falling bungee chamber. One of the bungee rope, okay, I don't know how we can be able to best pronounce this. It depends where you come from. Yeah, so the manufacturer states that the rope can withstand a maximum force of 8,000 newtons. For it to break, it can be able to withstand 8,000. Yeah, so on that regard, the teacher, that's Mr. Nick, was given that sample of a diameter 1 millimeter. Justify the teacher decision that could be saved. So the teacher is given a sample of the material with a diameter 1 millimeter, then was supposed to justify. We are supposed to justify the teacher decision that it will be safe for her student to determine the breaking stress of the sample. Remember, the breaking force is a property of a material. But let's work out the stress, and in this case the stress in this case is going to be, the stress here is going to be force over area. So we are going to use this data that was provided here, 2 centimeters. So we can find this was the diameter. We can be able to see the radius is going to be 1 centimeter. So which means we can be able to use this radius in order to work out the area. So we can be able to work out the stress of this material. And see, after we have gotten the stress of the material for that case, which is 2.55 times 10 to the power 7 pascals, we can be able to remember that the stress will remain the same. But for the second case, we are going to use the radius that was given here. This is the diameter. So we have to use the radius of 0.5 millimeters and work out the area. Then using the area obtained, which is in meter square, and the stress that we have gotten here, we can be able to calculate the force this material will be subjected to. And you can see the force that is subjected is what? 20 newtons. So which means 20 newtons is way below 8,000 newtons. And then we can say that the breaking stress is a property of a material, so it remains the same for both full rope and the sample that is given. So that's why you can see the stress that I am having here, I used it to calculate the force in the second case on the sample that was provided. Using the sample with 1 millimeter diameter, the force required to break it is around 20 newtons, which is safe for the student to apply using plastic lab equipment, and this is safe, appropriate decision for the teacher. So that can be a great bravo, a great congratulations to Mr. Nick who gave out that sample. You guys, I wish you all the best in your paper, coming paper. If you are new to Proflan YouTube channel, consider subscribing, and also you can be able to share these particular videos to your friends, encourage them to join Proflan, so that whenever we are going to work out Unit 4, Unit 5, and Unit 6, you will be also in Proflan YouTube channel. So remember to join our Patreon page so that you can be able to access the PDF of these papers that we are working here, and you can be able to access more materials which are in the Patreon page. We are almost done. Moving to the last bit of the question that was asked. To determine the breaking stress, the student used 100 gram slotted masses hung vertically from the sample. The maximum mass of the sample could hold before breaking was 1.9 kilograms, and the diameter was 0.95. So the manufacturer gives the breaking stress to be 2.55 times 10 to the power 7 pascals. So we were supposed to here work out the area, and the area, you need to remember you are given diameter. So this is where the student always get it wrong. You are supposed to work out area using the radius, but you forget that the measurement you are given is diameter. So you have to convert it to radius by dividing by 2, and also convert it to meters before you work it out. Otherwise, there is going to be a crisis, and you will cry after the exam, realizing that you forgot it was diameter, not radius. Don't forget that. Then we are going to have the force exerted will be the weight, so which is going to be mg, and working it out, we are going to get 18.639 newtons. And we shall now apply the formula for stress. Stress is force over area. We already have the force, we already have the area, so we work it out. We are going to get our stress to be 2.6 times 10 raised to the power 7. You can see the value the student has gotten is consistent with the manufacturer reading, which was given as 2.55 times 10 raised to the power 7 pascals. Basically, this is what you are supposed to do in this paper. Don't forget that most of the formulas are provided at the end of the page so that you can be able to use them. So most of the formulas, you can see the one that we've been using. Weight is mg, stress and strain, those formulas are all provided here so that you can be able to make use of them. You can see we have stress and strain, we have elastic potential energy, and also Young's modulus. I wish you all the best in your exam. Good luck, and make sure once you've done the paper, you come back to tell us, was the paper helpful, was the tutorials helpful, did you benefit from this tutorial? Don't forget to check this video that I've added here. It will just take you straight to some of the skills in this paper I've mentioned in other tutorials. See you in the next video.